So area of rectangles and parallelograms. It should be a review, but some people need that refresher. So over here is a visual. It's a little spotty looking, but rectangle A here goes up like this. And area is the amount of space inside. So that's a typical like carpet problem. How much carpet do you need, or how much dancing area do you have? So area is the space inside of a two-dimensional figure, and it's in square units. So you could count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But that would be monotonous when you have a rectangle, and it wouldn't be easy to do if you didn't have whole numbers for all of your dimensions. So instead, you typically are going to multiply how many rows you have and how many columns. So I have 4 by 3. That means I have 4 times 3, or 3 times 4, either way. And I have 12 square units. Another rectangle's over here, same sort of idea. I've got 1, 2, 3, 4, 5 across, but I have 3 groups of 5 across. So I have 15 square units. So for the first part of our notes, it's just about the rectangle. So the area of a rectangle equals the product of its length, and that's the lowercase l that I use the cursive loopy L, so it doesn't look like a 1 or an I, and its width, and that's the lowercase w. So if they give us 2 dimensions of a rectangle, we can find both the area and the perimeter. Don't get the two confused. Area is length times width. So in this particular rectangle, you pick one of your dimensions times the other dimension. You do out your computations, or if it's a day when I say you can use your calculator, you would get 6.45. And who can tell me what the units would be for the area of the rectangle? Yes, ma'am? So it's how many square centimeters I can count up inside, right? So square centimeters, or centimeters with the squared symbol after it. You cannot put that little raised 2 before the word centimeters, because otherwise you're telling me to square the number, and that makes a whole different answer. As opposed to perimeter, and that's where we're going to double one of the dimensions and double the other one, or add them up and then double it. In this case, it would be 2 times, I'm going to just do the 4.3 first, plus 2 times the 1.5. So 8.6 plus 3 gets me 11.6. And what's the units going to be for the perimeter? Yes, ma'am?
Centimeters?
Centimeters. So perimeter, remember, oh, if I put the string around it and then I laid out how long the string is, that would be measured in centimeters. But now we got to deal with the parallelograms, which aren't quite as easy as counting out squares, because you have those pieces that are sort of cut along the diagonals of the parallelogram. So our formula is going to be down here, but our visual is over here. If I have a parallelogram, I cannot multiply the outside dimensions. So I instead imagine taking that parallelogram, and typically they're going to give us a measurement inside unless it's on a grid like this. And I have the base goes across, and then the height goes up. And those are the 2 dimensions that I have to multiply. The reason is, if I cut this off here, I could translate it over here. 1, 2, 3 units across like this, and then it goes up, and then it goes like that. And what it does is it forms a rectangle. And that rectangle is the length of the base times the height that we just saw that they told us inside, or that we counted up with the diagram. So for this one, the area of a parallelogram equals the product of its base, and the base is going to be one of its side. Typically it's the horizontal, but not always, as we're going to see in the example. So it's one of the sides, and it's a lowercase b for the base, and the height. So the base depends on where we can find this information of a height. So the important thing is, the height's going to be the perpendicular distance from the base to its opposite side. That means it has to make a right angle between the base and the height. So the example we have here, find the area and perimeter of the following parallelogram. In order to use the formula, we're going to need to know which is the base and which is the height. But they give us 3 dimensions here. Because to answer both of these questions, we need these 3 different numbers. So who can tell me what the base and the height are based on the information they give? So this example right here, what's the base and the height? Yes, sir. The base is going to be 6 inches because what perpendicular distance from 6 inches to the across the way 6 inches do we know? What's the height?
3 inches.
3 inches. So the height's not always vertical and the base is not always horizontal. So here's the base because I know it takes 3 inches to get across to the thing across from it. And it's got a perpendicular relationship where it forms a right angle. So my area formula, area equals base times height. So 6 times 3. So it's going to be 18. And what's the units going to be in this case? Yes, sir?
Inches.
That's how many squares would be in there, right? So inches squared or squared inches. So remember, area is how much space is inside. A lot of times I look at the floor tiles and go, oh, it's how many squares. It's telling me how much space is there. So look at your floor tiles as opposed to thinking about a string. The perimeter, I almost call it a perpendicular. The perimeter, I'm going to use the formula 2 times the sum of the length and the width. Who can tell me what the length and the width would be? What are the 2 dimensions I need to find perimeter of this parallelogram? So raise your hand, you can tell me what the length and width I'll need to find the perimeter of this parallelogram. Yes, sir?
4 and 6.
The 4 and the 6. So I have to look at the outside dimensions to find perimeter. So 2 times the 6 plus the 4, or the 4 plus the 6. That's irrelevant which one you use for which. So 2 times 10, which is 20. And we're looking for perimeter here, so what's the units going to be? Yes, ma'am?
Just inches.
Just inches. So imagine that string. So for area, imagine how many squares are inside versus the string to go around the outside.